Hello and welcome to another episode of Crypto. Oh my god, I'm going to bring it back to the technicals today to fill you in on a little bit of information with what's going on really in regards to Ethereum today, which is one of the early blockchains that I got involved with. So I do have a lot of love for it, but obviously there's things like Solana and Aptos and Sui out there, and they're all doing really interesting stuff. But we want to understand when, you're thinking about where should you maybe hold some of your net worth, what are the trade-offs of these things? Today, I want to talk about scaling Ethereum and the implications because it's very important to that legacy asset that does hold the majority of the stablecoins on chain, the TVL, things of that nature. Anyway, let's get into it. Now, what kicked this off for me was a message I read coming from the block today. I saw it in a couple other places, but Standard Chartered cuts 2025 Ether price target by 60% to 4,000. Honestly, I'll take 4,000 right now. Of course, everybody was hoping 10K, etc. And the wildest thing coming from an investor landscape is like, what the fuck happened to ETH over this cycle? Last cycle, it was the place to be. It had the DeFi summer of 2020. It has all of the activity on chain, right? The growth, the stablecoin printing, the activity. Ethereum was so far ahead of all of the other programmatic blockchains that it's just kind of wild to see. And the reality is there's been technical trade-offs. A lot of this came since the merge or the move from proof of work to proof of stake. And of course, a lot of people inside the industry were very responsive to proof of work's electrical consumption. Now, it's my take that if you want to make hard money on the internet, it is reasonable to expect the resource to be the actual exchange rate of the universe, which is electricity, right? That's where Bitcoin's value comes from, the work that the miners use, which comes from real electrical costs. Now, the move to proof of stake took Ethereum off of that trade-off. There's no longer a high cost of electricity. The cost now comes in staking ETH and running a validator that's reliant on that. It could slash you as the downside versus having costs to running your business, CapEx. Now, back in the day, a lot of people were anti-Bitcoin for the electricity consumption. That narrative has changed a lot, especially with AI, which now consumes vastly more electricity, and we don't hear that conversation whatsoever. So it's always interesting to see where these talking points come into play, and I think, again, as always, there's larger narratives out there that like to spin micro narratives, and the anti-BTC camp really landed in that energy, green, sort of anti-environmental stuff. Obviously, with AI, enough people use it, the use case is so obvious, there's no stopping it. They are going to expand the electrical consumption base. And honestly, I don't think that we ever want to constrict our electrical demands. Our goal as a society should be to produce more electricity. It is infinite out there in the world. We just need to figure out how to harvest it appropriately. Now, back to Ethereum and Standard Chartered. What we have to realize is Standard Chartered, traditional banks, they understand valuations. When they do diligence to value an asset, they go deep into understanding the what, the why, the how, right? Now they're coming out, and I think the main point here is we estimated that Base, the dominant L2, has removed 50 billion of market cap from Ethereum alone. And this is the core of what I want to talk about today. The main conversations inside the Ethereum circles are that the L2s are earning lots of revenue to the tune of 50 billion, right, if we're just taking on Base, and that they're not paying enough for the rent that they get. So what are they doing? They're sitting on top of Ethereum. They are leveraging its security, so all of the technology and assets inside of it that have been developed for the ETH ecosystem create this very secure, decentralized network. But that security comes with costs. There's the trilemma that it can only be so fast, so cheap, or so decentralized, right? So that security, decentralization, comes at the cost of speed and actual cost, how the gas price. Now, that being said, we need to scale it, right? The trade-off between a standard centralized network and a decentralized network is enormous. A standard network like Uber is millions of times more performant than a decentralized network. The way it coordinates users and pricing and all of these cabs on the road, it makes a blockchain network look like pittance, right? It just completely overshadows them. But of course, Uber operates that. and they keep that all under their control, and it doesn't really matter. We need it to work. Now, when you're talking about decentralization, anti-fragility, right, being government resistant, making money that competes with the global monetary system, you need to trade all of that for the security and the decentralization. Those two things go hand in hand. They're slightly different, but that is where the big trade comes from. So these networks are much slower. They have a heavier lift to coordinate globally. And in Ethereum's case, to add to decentralization, they want smaller players to participate. So Solana, in its big trade-off, relies on very heavy validators, big systems that requires a systems architecture expert, a data center, a lot of heavy lifting in terms of what you might see in a more normal network. Ethereum went the other way. They said, we want people to run these at home on small little Raspberry Pis, and they should be able to contribute and blah, blah, blah. So these are philosophical differences, and we're not going to get into it. But in a nutshell, when we look at these decentralized networks, they are slower, they are heavier, and that's the trade-off for, again, being anti-fragile and being able to provide what is that moneyness. If you put moneyness on an Uber server, Uber could just adjust it however they felt like. It wouldn't work. It defeats the purpose. So Ethereum came up with L2s, and they've gone into this modular thesis, right, which is that different components can compete and anyone can build on top of Ethereum's L1 security. So instead of scaling that base layer to accommodate all the applications, like an Uber on blockchain, they're going to allow L2s, or a layer on top, to be able to do that, because the L2s can sacrifice security. They're basically going to be offering a function in a small time frame, and then they will use that function in that time frame to condense it into a single transaction, which goes on to the Ethereum L1, securing the security. So anyone can pull up that transaction data later in the future. It lives on Ethereum. Now, while it's insecure for the moment, the second it gets pegged into the Ethereum L1, you have a secure state, and you can bring that state back into reality at any point in time. Anyway, fun stuff. So let's just get into this really quickly. As we look to visualize the Ethereum ecosystem, you can think of these machines, these blockchains, as actually many components. And this is a really great breakdown. This is coming from a Medium post from Jeremy Posvar. I will post it, and this is an excellent article, so you should just read the whole thing. But we can look at the wallet users, right? This is the UI, and this is very broad. A lot of people build a lot of different UIs. You have the transaction layer, the queue, and this is the mempool, right? Everybody puts their transactions into the mempool, and then the execution layer will actually order these things. This could be through smart contracts. This could be through a variety of different mechanisms. This is also where we get MEV, which is maximally extracted value, where people can actually look at the mempool and say, hey, there's a bunch of transactions going on here, but if we order them in a specific way, we could maybe add in our own transaction, like a sandwich attack, which says, hey, I see a big buy order. Let me put a buy right in front of it and a sell right after it. And in a same block on the execution, they can make an atomic swap and a trade for profitability. So there's actually an entire marketplace inside the execution layer, which is very complex, and maybe one day I'll get into. Then, of course, you have consensus, right? You're locking in these blocks. We're all executing. So did that executed block get socialized across all of the validator nodes? We have to have consensus that all of these transactions did indeed occur, right? That's basically what's happening there, and that's its own layer. And of course, this is independent pieces of code that just create consensus across all of these decentralized nodes. This is the part that really slows things down, but adds security. So in a centralized system, consensus is easy because it could all happen on a single node. You don't really need it. You're not reaching across the world to get consensus across a broad body, right? That's the big trade-off. And then, of course, once you have consensus, you need to pack that data up and say, this is what we all agreed happened. And where do you store those data on previous blocks? Now, that data availability layer is built into Ethereum, and that is something that ETH offers at a very low rate. What we've seen is with other things like Celestia, they've broken off this data layer into its own product to make it highly scalable, much faster, much cheaper, and basically say anyone that wants to store data can store it here. And maybe we store things that are not just transactions. Maybe we start storing information. It really depends on the specifics of that data availability layer. But you can see that there are multiple components inside a Solana ecosystem. They would keep all of these on the L1, basically saying when all of these happen together, any app can compose on top of each other. So if you build an app that makes swaps and an app that makes loans, you can build an app that takes a swap, places a loan from your wallet, right? Things like that. Whereas in Ethereum, if they begin to build different takes, they might not cooperate or interoperate with each other. As mentioned by Standard Chartered in the beginning, Base is taking a lot of the value. They saw $50 billion of what would have been captured value on Ethereum going to Base. And Base pays very little. They only have to make one transaction because they roll up all their transactions into one and they put that on the L1. So Ethereum is not capturing a ton of value. And we look at L2s, and to be fair, these do include some like Bitcoin L2s, but these are mostly, so Bob is Bitcoin, Starknet is Bitcoin. But anyway, these are mostly Ethereum because that's the L2 ecosystem. And you can just see there's a lot, right? And like, how do we understand these things? Now, we had the merge a long time ago. This was really cool. It was basically like changing the engine in a car while it was driving down the highway. That's because they needed the Ethereum network to continue processing transactions while they also swapped out the heart of the engine, which was the consensus mechanism, going from proof of work to proof of stake. Now, it did not scale. What it did was it opened the opportunity for other people to begin to scale. And this was a really fun and interesting moment in time because that's when we had the Great Schism. This is also when Ethereum began to lose some of the value that we're talking about today, something that we hope to repair through future developments. We start with L1, so dank sharding, and this name comes from Dankred Feist, which is a developer. And this looks at just actually taking some of the processes of a node and breaking it down into smaller shards. So we take a complete element, we break it up, right? Basically make smaller chunks. It's a way to think about scaling the L1 itself. And that is just taking nodes and making them into smaller nodes. We can think of it that way. Kind of a reduction, but this is by Genesis Block. And here we have what is proto-dank sharding. Proto-dank sharding, also known as EIP 4844, is a way for rollups to add cheaper data to blocks. Again, these blocks, they need to pull data from the past in order to execute on the future. This needs to be cheap storage. We want to store as much as we can for as little as we can. The name comes from two researchers, Proto Lambda and Dankred Feist. And right now, rollups are limited to how cheap they can make user transactions by the fact that they post their transactions in call data. This is expensive because it is processed by all of the Ethereum nodes and it lives on chain forever, even though the rollups only need data for a short time. Proto-dank sharding introduces data blobs that can be sent and attached to blobs. The data in these blobs is not accessible to the EVM and is automatically deleted after a fixed period of time. This means that rollups can send their data much more cheaply, saving transaction fees. Now, one of the most common rollups and really one of the more ready to ship, even though they're all quite difficult rollups that we're seeing, are called optimistic. This optimism comes in the fact that they are taking the optimistic stance that most transactions are actually true. They're not nefarious or trying to game the system. So it's just going to pass through transactions with an optimistic take that they are indeed valid. And if one of the validators that is reviewing posted transactions find something that's BS, they can call it out later and they can slash in response. So basically the machine keeps churning and there are watchers overseeing what's happening. Now the rollup itself in optimistic, and this is optimism, which Base is built upon, it basically allows them to have a centralized server in the office. And that server, since it's centralized, is way faster, right? It's way faster, way cheaper because it's really just a ledger saying all these users transacted. Now, it's less secure because somebody is running it. It's a centralized sequencer sequencing the transactions. But after every so many transactions, it basically takes that data and it posts to the Ethereum blockchain on the L1. So once it's on the L1, those are final and those are secured. It can no longer go back in time and adjust those transactions or make any sort of malicious changes. It inherits the security of the Ethereum L1. But as you can see, it is permitted to order all of those blocks. It could be doing MEV to generate its own revenue. It could be taking fees from all of those users, but all it has to do is bundle that up and pay for the fee of one Ethereum transaction. So you can see it is not really paying the rent for the security it's gaining, and that's one of the topics we're talking about. And this is a pretty easy to read overview of how rollups work. Now, then we move on to zero knowledge, and I think this is truly the future. It's just very difficult. It's complex mathematics, but I've talked about ZK in the past, and I do think it is the backbone of how blockchains act as the truth layer for this digital world that we're moving into. So in a zero knowledge rollup, we can actually understand that a transaction is true via the prover network. So basically the transactions continue to go through this rollup. Similar, it's a variety of transactions happening in a chunk. We don't need to know anything about their data. They're running through mathematical proofs, and there is a prover network that sits inside, basically confirming that yes, this transaction is valid, it has occurred. Once that all happens, it condenses the rollup and it sends one fee to the Ethereum L1. Similarly to the optimistic, it's just that now each transaction is being verified as true by a prover. It also means that there's less information about the transactees. This is where we really get to take identity and identifiers and split them up in a way that's very healthy for the digital world. This allows us to make transactions on chain without them being directly tied to our personalities. This is about privacy. Then, of course, in a different world outside of rollups, we have state channels. I'm not as big a fan, but they do have some utility in certain cases. A state channel is actually an off-chain settlement network. And this really requires users to open their own state channels, and it's a little bit more privately organized. And this is largely where some of the Bitcoin networks have settled on, right? What happens here is that a group of people open up what is called their own state channel. They basically make transactions amongst themselves to their heart's content. And when they're concluded, they settle all of those transactions and they send one message back to the L1, basically saying, myself and two friends have done all the trading that we could so desire. We're going to lock it in the permanent security of Ethereum and settle it back. State channels are not so utilized for this reason, that they're a little bit more private, less public. Now, we also have this concept, plasma. It's a little bit more technical. It's an extension of the Merkle tree. And the Merkle tree is basically the giant thread of transactions. Basically, wallet X sent money to wallet Y and wallet Z. And it continues to extend down like a tree. And it's getting really complicated, so maybe I can utilize this broader image of how things work, which is that really this is how we see a traditional transaction. I'll zoom in a little bit more. You have the block body, right? A block is a list of transactions that is being condensed and submitted to the network. Blocks create a history, and we get the history via a blockchain. So we have a transaction 1, transaction 2, so on and so forth, with the block header basically being the information of where this relates in the chain itself. Now, when we look at a lot of these other elements, like a state channel contract, which is just a closed loop, we can sort of ignore it, but a ZK and a rollup is taking these compressed transactions. That's what these rollups are, right? They're rolling up a bunch of transactions, compressing it, and putting it into this chain. Now, Plasma runs sort of a mini blockchain in easy terms, putting it back in the state root, and this allows it to validate a fault-based L2 mechanism. So it's a way to mathematically validate and scale these networks. And maybe we're going to take a bit of each in order to make the future version of crypto, or bridges and cross-chain solutions will allow for the flexibility to take advantage of the best features of each of these things for different utilities, right? For different applications. Now, lastly, we have a Validium, and a Validium is a scaling solution that enforces integrity of transactions using the validity proofs like ZK rollups, but doesn't store transaction data on the Ethereum mainnet. Let's think of that DA layer, right? While off-chain data availability introduces trade-off, it can lead to massive improvements like scalability. So Validiums can do 9,000 transactions or more per second. And here's a really good take from Vitalik on where these things kind of sit, right? So this is the simplest description of what are the trade-offs of each of these crazy things that I've gone over, right? Is the data on-chain? Is the data off-chain? Is it with a Stark or a Snark? Are the fraud proofs, again, figuring out if there's malicious intent on the chain, how are they working, right? So if it's data on chain and you're using zero knowledge, then it's ZK rollup. If it's off chain and you're using ZK, it's a Validium, so on and so forth. And you can see that these do have little trade-offs, and I'm sure they will be merged. According to this, something like Celestia could potentially be a Validium or not a Validium. I believe it is data availability, and depending on whether you want that data on-chain or off-chain really defines it. So in Celestia, you can store that data off-chain, a Validium. You can keep it on-chain. And there is utility to on-chain. It means it's verifiable, cryptographic. and it stays there forever. However, with a lot of the call data, like maybe older transaction history on dumb things like, I don't know, card games, right? Things that aren't really relevant to a video game or something to that effect, you might not need that data on chain. Something like banking features like finance, you probably do. So it really depends how long you want to hold this data, because what is the end goal of what you're trying to do? And I come back to this because it's really the best visualization. I'll have a link for it in the descriptions, but I highly recommend that you open it and kind of give it a gist to look at what's going on with the different scaling solutions behind Ethereum. Now, to come back and loop it all to what Standard Chartered was saying was that currently these things, and they're just not paying enough rent for the security, right? They all are able to create these businesses that capture value, lock it in, and all they have to pay is a single ETH transaction. And with all of these things bundling up transactions in their own little roll-ups, that means there's less stuff happening on ETH. So ETH transactions have come down in price too. When I want to do a big DeFi trade, I might like to do it on the L1 because it provides a lot more security and it's not that expensive anymore. The age of $100 fees are gone because all of these rollups are taking that transaction data and, again, rolling it up. So this is a really interesting conundrum for Ethereum at the moment. They're trying to figure out how they should approach this. Basically, the people running Ethereum have a very open source kind of vibe. They say this should basically be free. This is a great feature set. But if you're long Ethereum, if you want to provide to the network, you need some value accrual, right? Or you feel like you've missed out and the contributions aren't worth it. If we're going to see these L2s become businesses, businesses want to maximize their revenue. It's just the nature of the game. And if they're taking all the money from the network and not paying anything for security because it's basically free, then like Ethereum's kind of getting gypped. And this is where people are at right now. They're saying we're tired of getting gypped. We built this amazing tech stack, and other businesses like Coinbase, which is centrally operated and its value flows to coin, the equity. It's like, hey man, this trade-off ain't right. So Solana comes in and basically says you can build everything on our chain, you can build an entire app, and that value stays on Solana. This is really the ebb and flow, the push and pull between these two ecosystems. This is where the beef originates from. Luckily, we've had a nice come to Jesus moment around this with Ethereum as they see they're losing out to Solana, both on attracting new users and also that they're getting kind of gypped by the people that are building on top of them. So even if they do build a Solana competitor on the L2s, are they going to see the rewards from that, right? This is the moral dilemma coming out of Ethereum. How do we build this infinite garden? That's been the beautiful vision behind it, but how do we also earn our just desserts from the work that we've put in? The worst thing that could happen is that, Robinhood launches their L2, gets all the users, and makes all of the money from all the hard work that's gone into this. Anyways, I hope this helped you understand a little bit more about what's going on right now. Again, these are very dynamic ecosystems. A lot of these problems can be solved. There are review processes. There are the Ethereum improvement protocols. They've launched Etherealize to go after the larger, more institutional capital providers, saying Ethereum remains the most decentralized, trusted network of them all. And if you're going to put big money on chain, it should be on Ethereum. Of course, lots of USDC and stablecoins, USDT is finding a world on Ethereum. So this is all developing and unfolding. And at the end, maybe made the best chain win, but also when we put an LLM layer on top, are we ever going to even know what chains we use? I don't know. So hopefully this was a little useful for you. I'll put all of this information in the reference material. It's a lot to chew on, so by all means, spend some time with it. And as always, good luck out there, guys. I'll see you tomorrow.